Hi guys, I'm Isaac Kipng'etich. I will be taking you through Pigeonhole principle, and I hope you will be able to learn many concepts about Pigeonhole principle. So, for example, let if you have, for example, let's say you have three pigeonhole and four pigeons. So, for here, let me demonstrate it like this. So, the first picture, these three pigeon holes, and we have four pigeons. So, we have the first pigeon there, the second, the third. So, the fourth pigeon, you will be able to fix anywhere. This is where now our principle, the pigeonhole principle concept will apply. So the extra one might be here or here or here. So let me just now divide our pigeonhole principle using this concept. So the pigeonhole principle states that if n pigeonhole are occupied by n plus 1 or more pigeons, then at least one pigeonhole occupied by more than one pigeon. So our concept here is about the pigeonhole principle. So instead that if n pigeonhole are occupied by n plus 1 or more pigeons, then at least one pigeonhole occupied by more than one pigeon. So here we have one pigeonhole is occupied by more than one pigeon. So that is where the concept of pigeonhole principle stays. So let us see some examples about pigeonhole. So, for example, you have one, two, three, four. You have four pigeon hole, and then we have 3 pigeons. So the first pigeon will be here, the second one that way, that way, that way. So the way I had already explained for you about the meaning of the pigeonhole principle. So the first, the extra one, the fourth pigeons will be here. And that is where the concept of pigeonhole applies. So let us see the second example. What is the minimum number of people I need to ensure that two people share the same birthday. So here the concept applies. Our n, we have 300. The question says, what is the minimum number of people? We want the minimum number of people in need to ensure that two people share the same birthday. And we know in a year we have, when a year is leap year, we have 366 days. So in these 366 days, at least there should be two people who share the same birthday. So our formula will be n plus 1. That is where we will be able to obtain our minimum number of people, who is those who are born, those who share the same birthday. So our n is 366 plus 1 will be 367. So let us see the third example. So that was the basic about the pigeonhole principle. So let us see about the generalized pigeonhole principle. So this generalized pigeonhole principle, it states that if n objects are placed into k boxes, then there is at least one box containing n over k objects. So if n objects are placed into k boxes, then there is at least one box containing n over k objects. So I hope the statement is well understood. So for us to understand more, let us see some examples about this generalized pigeonhole principle, and I hope you will be able to understand more about it. So the first example is among 50 people, what is the number of people that must be born on the same month. So here, among the 50 people, what is the number of people that must be born on the same month? So we know in a year we have 12 months. So we have 12 months in a year. So our K will be the 12 months of the year. And our N we have been already given, which is 50. So in here, the way I informed you before, that our formula will be at least in a year there should be at least some people who are born on the same month. So we will be able to know how many people are born on the same month. So if you divide 50 divided by 12, will give you 4.16. So in this 4.16, you won't leave it this way. You have to round off to the next integer. So our next integer will be 5. So we have, among the 50 people, what is the number of people that must be born on the same month? So the number of people that must be born on the same month are 5 people. So let us see almost the last example. So, how many students in a class must the same thread. So here we have one of A, B, C, D, and F. So how many students in a class must be there to ensure that 3 students get the same grade? So here we have how many grades here? A, B, C, D, and F, which is 1, 2, 3, 4, 5. So our K will be 5, and our N will be here. We have 3. So and our N over K. So our answer will be 0.6. So I informed you earlier that you have to round off to the next integer. So which will be 1. So let us see the last example. Suppose a computer networks consists of 6 computers. Each computer is directly connected to one another, one or more of the other computer. Show that there are at least 2 computers that are connected the same number of other computers. So the question is, a computer network consists of 6 computers. Each computer is directly connected to one or more of the other computer. Show that there are at least 2 computers that are connected to the same number of other computers. So we have one, 2, 3, 4, 5. So the computers consist of 6 computers, and in our Pigeonhole principle state that at least one of the computers should be one of the computer is connected to the other one. So here we have 6 computers. So at least one computer will be connected to the other one. So 1, 2, 3, 4, 5. So these 5 will be our K, and our N now will be these six computers. So 6 divided by 5 will be 1.2. So the way I had already informed you earlier that you have to round off to the next integer. So the question was saying show that there are at least 2 computers that are connected to the same number of other computers, and we have already shown. So thank you for being in and for learning more about the Pigeonhole principle. So I just want to tell you that let us subscribe